So, while Rebecca is plugging her gear, I quickly asked her, how would you like me to present you on stage? She gave me a great idea. She said, do you see this gadget over here? That's an insulin gadget. So she said, basically, all these developers inside the hall, they can really hack into me. So if somebody is interested. Oh, okay, that's not an invitation. Apologies. So other than that, she's coming from Amsterdam. She's working there as a full-stack JavaScript developer at Usabilla. It's a very cool tool for product people like me. So I think in a couple of seconds, she's ready. And after her talk, there's going to be a lunch break. Food will arrive. So bear with us. Good. Round of applause, please. Yes.
All right, I think I've got this mic situation under control. Yes? Okay, cool. All right, hey everyone. So, so I come from a company called Usabilla based in Amsterdam, and we're kind of a feedback solutions company. And I've been working with React and its friends in production web apps for a few years now. And each time I've gone to build an application with React, particularly when it starts to scale, I found myself struggling with this question: where does all the business logic go? React takes care of the UI, and there are heaps of great tools for state management, but where does all the tricky app-specific stuff go? Well, there is no one answer to this, but I have a few ideas that I'm going to share with you. I'd love to hear your thoughts also on Twitter. I'm at Rebecca, so feel free to tweet at me. Okay, so what do I mean by business logic? Well, generally, this is the code that handles the application of your real-world business rules. So say you have a pet store. You might have a rule that says that when a customer buys a tarantula, that they have to fill in a form to say that they won't use it to scare their neighbors. Well, if you decide to start selling online, then this code, it needs to be somewhere right in your application. For security and performance, much of this stuff will be in the back end, but as apps get more responsive and dynamic, more and more of this business logic also exists in the front end. Okay, so let's split this up into three main areas. First, we have data manipulation. So this is where we do our aggregation and filtering of our data that's essential for our business. For instance, say we're working on a website that displays a user's profile. Well, some of the data might come from user input in the state, and some of it might come from an API endpoint. Or we might want to merge that data in a specific way, say making the user input take priority. And then we might have some conditional business logic. For instance, on Chrome, if the user doesn't have an internet connection, then they get shown a cute dinosaur game. And lastly, we have the area of asynchronous data flow. So this is the logic that handles API calls and manages the success and failure of them. For instance, we might have an app that translates text real-time to emojis, and we're going to need some specific logic in order to make that call to our translation service seem smooth to the user. Okay, so the problem with business logic is that these days there's no one solution as to literally where to place it in your app and what tools to use to manage it. And why not? Well, because by definition, business logic is unique to your use case. There are many options out there, especially in the React modular ecosystem. And the right decision for you will be based on the needs of your application, your team's experience, and also just personal preference. There is no one perfect answer. The good news, though, is that this means that you can build the framework that you need, include the tooling that you need, and nothing more. You'll end up with a structure that really works for you and your application, and can grow with your specific requirements. Whatever you choose, though, and especially once your app starts to scale, the main thing to keep in mind is to decouple your business logic as much as possible from the rest of your application. For instance, avoid including business logic in your UI components. This makes your logic much easier to test, easier to change, pull out altogether and throw away, reuse, iterate on, and also read. So the main focus of my talk is going to be on web apps with lots of pages, lots of complexity, developers, and business logic that somehow needs to be coded in a way that's easily manipulated, tested, and extended. And most commonly with React, that also means using Redux for state management. So that's why I'm going to focus on that kind of app. However, please remember, of course, that not every app suits Redux. And when you're building an app, make sure you really understand why you need it. Maybe standard React state will do you just fine. Or maybe another library like MobX suits you better. And if your only requirement is avoiding to pass down heaps of data through props, well, maybe you could give the brand new React Context API a go. This also means that if I recommend for or against something in this talk, but the opposite is working better for you, then keep doing what you're doing. My goal is just to give some guidance to people who don't know what works best for them yet, and maybe some assurances that, well, no one really knows because no one can see the future. In any case, the principles of the approaches that I'm describing should be applicable in any situation. So, there we go. So a very quick recap, just in case you haven't used Redux before, so you're not completely lost. The key to Redux is a predictable data flow. In other words, components use action creators to dispatch actions that are picked up by pure functions called reducers, which create new versions of the state for the store, which is read by the components, and everything starts all over again. A thunk is a commonly used special type of action creator provided by an external middleware package called Redux Thunk that gives greater flexibility. Okay, so let's start with data manipulation, our first area, and a real-world problem. Say you have an online store that sells books, and you want to show your users a filter on the left-hand side that lists just your best-selling authors, and when someone selects an author, only books written by that author display. Well, one way to do this would be to retrieve an API that returns an array of the possible authors that your store stocks, inside each of which is a Boolean is bestseller. You would then manipulate that data to create yourself another array of only best-selling author names. Well, doing that actual filtering is pretty straightforward, but in a React and Redux app, where should we put that function? So the first instinct that many developers have, especially those new to React, is to put that logic straight into their components. Here we have a product list page container component that renders a filter component that displays the list of authors. To do this, in the render function, we have the filtering that we talked about. And we're then passing the result of that into the filter component. It's simple but pretty effective. And as soon as you need to do this multiple times, or for multiple different pieces of data, or you want that same filtering function elsewhere, or even if the filtering function itself is more complicated, things can get really messy really quickly. In other words, as a general rule, business logic should not be in components. Another option that sometimes occurs to people is to put this logic in the reducers. So in this case, our reducer is receiving an action containing the authors array. It's creating the filtered best-selling authors array, and then setting both into the state so that the components can get whatever they want. The biggest issue with this approach is that we're now storing duplicate data in the state. What happens when we need to update a property on a specific author? Well, we'd have to manipulate both arrays. We should always avoid putting data into the state if it can be calculated from another part, as it makes it a lot more difficult to manage and increases the likelihood of our data getting out of sync. We also have similar issues as with the components option. Our filter is not able to be reused like this, and the reducer has become more difficult to test, read, and change because it's now responsible for doing multiple different things, both for filtering the array and for updating the state. We also will have the issue that the reducer only has access to the part of the state that's being passed into it. And with a largish application that combines multiple reducers, this can be tricky. So say if our author list was also filtered by, say, a user input from somewhere else in the state. Most of these issues also apply to your action creators or thunks. Here we have a normal action creator receiving the JSON response from an API and sending both the original author data and the derived best-selling authors data to the reducers to include in the state. Well, we're still duplicating the data in the state here, so this option also kind of sucks. Fortunately, we have selectors. So this concept gives us a single consistent way to accomplish these kinds of data manipulation tasks. Here we have a reducer file that includes a get best-selling authors selector that contains our filter. And then in our product list container, we use the selector in the Redux map state to props function. In this simple form, it's really just a nice utility function with the convention that it accepts the state object and returns the derived data. This means it's easy to work with and it can be used in any place that knows about the Redux state, usually components map state to props or in middleware tools. They're kind of like database queries for your Redux store, and even really small apps can find them pretty useful. The key though is to be consistent. By containing all the knowledge about your state shape in your reducers and selectors only, rather than dotted around your components and middleware, refactoring becomes a million times easier. It also means that Redux only needs to store the minimal possible state, making it much simpler. Ugh. Wow, where are we? That's going to be fun. Okay. Yes, cool. And the last option for data manipulation that I want to talk about is Reselect. This is just an external library that enhances the selector concept, especially when your app really starts to scale and performance is more of an issue. Here we have our get best-selling authors selector, which still takes in the state and returns the filtered list that we want, but this time it's using create selector from Reselect. By doing so, we've created a memoized selector. This means it only recalculates the list of best-selling authors when the value of get authors changes. So if an action affects any other irrelevant part of the state, this calculation doesn't occur, which can provide big performance benefits, especially in large applications. It's worth a quick word of warning though. Make sure you test to check that what you think is happening is actually happening with the memoization, because especially when you want to start passing props into your selectors, there are a few additional things to implement to make sure that you still get those performance improvements. So next up is conditional business logic. Let's say that our bookstore only sells really rare one-of-a-kind books, and there's a business rule that customers can only buy one of each book. So we need to add some validation to check that when a user tries to add a book to their shopping cart, they can only do so if it doesn't already exist there. Again, the simplest option, and something I've seen a lot, is just adding this logic in the component. Here we're handling the click event that runs when a user clicks the Add to Cart button. If the cart items array includes the ID of the book that's been requested, then we're returning early out of the function. Otherwise, we let the user add it to the cart. Like last time, this is super easy and it does the job. But even in very small apps, it feels pretty gross. We have business logic here at the very front of our app where it simply doesn't belong. The UI has enough to deal with. So what if we did this in our action creators or thunks? Well, here we have a thunk called Conditional Add To Cart. It's called when the user clicks the Add to Cart button. It uses a selector to get the list of current cart items from the state to check if the new book ID is there. If it is, then we return out of the function. If not, then, well, we're allowed to add the book. So the benefit that thunks here have over normal action creators is that A, they have access to the whole state, so we don't have to pass that cart items list through the function. And B, they allow you to return whatever you want, including undefined, which is what's happening here if the item already exists in the cart. This is not that bad an option, and it is perfectly valid if it works for you, but after a few years of working with Redux, I typically lean away from this in the majority of cases. Personally, I try to err on the side of putting more logic in my reducers. Conceptually, reducers are designed to look after the state of data. The principles of Redux are that actions are an object describing what happened, and state is read-only, changed by pure reducer functions. The point is to decouple what happened from how the state changes. And action creators like the one I just showed before kind of steal all that logic away from the reducer. It kind of just tells it what to set in the state, which defeats the purpose of that separation. Some might think, oh, but I don't want to fire off actions if they're not needed. And that is true, especially for async actions, but reacting to synchronous actions and determining whether and how to change the state, that's the whole job of a reducer. There are a few benefits to favoring reducers for your conditional business logic. They're pure functions, of course, so much easier to test and maintain and refactor. It also means more of your logic is more easily covered by debugging tools. You're also less likely to dispatch a bunch of actions from your thunks that cause the UI to re-render, which can cause performance issues, and the store can sometimes get to be inconsistent. So now data access. What's the best way to retrieve our array of books in the first place? We want to get the data from the API, show a loading animation, and handle the success and failure of that call. By the way, this is a very simple use case, which I'm using just to explain the following tools. But keep in mind that if this is the most complex data flow that you have in your app, then you probably don't even need to use middleware at all. I'll show some more simple and more complex examples afterwards that will really demonstrate the usefulness of these approaches. Okay, first let's look at Redux Thunk. In our example, we have an action creator called loadBooks, which is dispatched when the page first loads. Its first task is to in turn dispatch the loading books action, which sets a loading animation to appear. It then calls our API service to fetch the books. And if successful, it dispatches the success action with the result of that API call. And if it fails, then it dispatches a failure action, from which we can decide to display an error message. And both of those actions also remove the loading animation. Thunks are a great place to start with when you're working with React and Redux applications. They're relatively simple, and they use the action creator pattern that we're used to. And they allow you to write normal promise or async code inside them. However, there aren't many options around dealing with multiple requests to the same action. They can be difficult to test because they directly deal with side effects, which usually have to be mocked. And if you're working with a large application, it can get pretty messy pretty quickly when you're using the same tool to do multiple things. If you're finding that thunks are not working for you and you need something a bit more powerful, then one of your options is Redux Observable. This library is a Redux-specific implementation of reactive programming using observables. It's based on RxJS, and it makes it easier to compose asynchronous code. The core primitive of Redux Observable is an epic, like our loadBooks epic here. These functions accept a stream of actions and return a stream of actions. So in this example, essentially we're listening to the stream of potential loadBooks actions in the app. When the page is loaded, our component fires the action, and this epic picks it up. It calls our API service and then returns either a success or failure action. Compared to thunks, Redux Observable is really powerful, and it provides a lot of techniques for handling complicated process flows in your app. For instance, you can cancel actions, throttle and debounce them, or choose to only act on the latest. They can also be very separate from your action creators, meaning greater modularity and cleaner code. However, as you can see, if you're not used to the syntax, there's a fair bit of complexity to understand here. This library has a steep learning curve, and reactive programming is a completely different way of thinking. Also, the stream concept and approach to side effects can get tricky to test sometimes. So lastly, we have my personal favorite, redux-saga. Saga is actually an Old Norse word, which means a long dramatic story, so it's pretty applicable here. Redux-saga uses generator functions, which you can see from the functions with the asterisk by them and the yield keyword. They allow sagas to be like a separately running thread in your application, and they mean that your code can be read like standard synchronous JavaScript, kind of like async await, but with a few more awesome features. So here we have a books saga, which takes every load books action that's dispatched throughout the application, and it calls load books. Load books calls our API service to fetch the list of books, and it returns it into the book data variable. The function waits for that to complete, that's the key bit, and if successful, it dispatches fetch book success. And if there's a failure, it dispatches fetch books failure. The benefits are similar to Redux Observable, in that A, we have a lot more power about how and when we react to actions, and B, our side effects are separated from our action creators for a clearer definition of responsibility. Generative functions can also be a bit of a learning curve, but for me personally, they have a few advantages over Redux Observable. For one, Sagas are easier to test. You don't actually need to mock anything because all you need to do is test the instructions that they're sending. The way that redux-saga works is that each of these keywords here wraps the function that's happening. And their greatest strength is how they organize your code. The Saga functions like call, put, select, etc. are really readable, and the yield keyword means that they can be read like synchronous code. Situations where something like redux-saga really shines are things like a complex reauthorization flow with tokens or a step-by-step onboarding process. And in my opinion, any Redux app over a certain size. Cool, so now for some actual real-world examples. Some of these I've built, some are built by others, but I think they're really great examples of how to handle this business logic, and they're open source, so you can check them out on GitHub. So I'm going to start off with something really small. Assuming that your app is of kind of a small to medium size, this approach could easily work for you too. Remember, don't include extra tools and complexity if you don't need it. So it's a little app I made with Create, React App, and Express. It lists a bunch of solved cases for a detective agency with the ability to filter by year. So you can click through the app and check out all the different solved cases. So first off, the file structure. Because it's super simple, I've stuck to the Rails style easy separation by file type. And here's the main container component for the app. If we start by looking at the business logic for async flow, we can see that component demount here is actually async, and it calls our mystery service. And the actual API call has been abstracted away into this service so that it's easier to test and update, and it gives us that better separation of concerns, especially if we want to add any complexity here in the future. Next up is the data manipulation business logic. Here we're getting the list of active mysteries to render. Note that we're using the selector convention and passing through the state, even though we're not using Redux in this app. And in the selector, we're returning the filtered mysteries based on the active filter. By splitting these things out, our logic becomes super simple to use, change, and test because it's a pure projectable function. And next, here's a really cool app from Joshua Como that lets you play around with the web audio API. It has a really smooth onboarding process, which, as I was saying, is a perfect use case for Sagas. So as you click through, you're kind of taught how to use the app. Each step is based on time and on key presses and mouse movement from the user. It doesn't hurt that it's really beautiful to look at too. So if we dive into the code, you can see that he's also structuring his app Rails style. And here are the selectors. In this app, they're located inside the reducer files. And for conditional business logic, if we take a look at this go to next stage action creator, for example, you can see that, well, there isn't really any logic here. But with the reducers, there is a fair bit. It's responding to that action and figuring out which stage to return. And in this onboarding saga, it's picking up that same action. It's going through each of the onboarding steps and then handling a side effect and saving a flag to local storage. I really love the readability of this app. And here's a React Native app by Nick Graff that keeps track of your vaccinations. A nice addition here is that the reducers are using immutable.js to protect the data in the state from being accidentally mutated. And in the Sagas, we have this generator function, which is calling another to persist data to storage on the mobile device. And lastly, the selectors. Interesting to note here, they're not in the reducer files, but each slice of the state gets its own file just for selectors. I find apps differ on this a lot based on size and personal preference, but I don't really think it matters as long as your state is still easy to refactor. Also, note the use of Reselect here. And here's quite a large app in contrast. This is a previous project of mine that lets businesses manage their clients. This app is also structured Rails style with folders for actions, components, reducers, etc. But the components folder in particular was getting really too big. So we did split that up by high-level route with a folder for shared common components. If this app had continued to get even larger, we may have considered moving the other tools like the reducers and actions into the route structure, but at this size, it felt pretty workable and was really nice to navigate around. So here's an example of conditional business logic in one of the reducers. You can see a couple of instances where utility functions are used to make calculations that determine how to update the state. For instance, this toggle filter utility here. And now the async logic. Here's the search clients saga, for example. Using the take latest method from redux-saga, we're saying here that we only want the latest search client action, which is pretty cool. It means that we do fewer unnecessary calls to the API. Here's another example, a saga for editing notes. First thing it does is an API call to save the new note data, and then it requests all the updated notes from the server. Then it's adding those notes to the state, resetting the editing route, and then shows a successful notification to the user. And that's it. I love how easy this is to follow what's happening once you know the syntax. Sagas really let you write the process flow of your application. And finally, here's a moderator app I built for a game called Werewolf. So games have a lot of business logic because there's a lot of process flow to control. The options available on each step heavily depend on every action that's taken before it. This is quite a contrast to a traditional app, which is more like a spread out list of options with less dependencies in terms of process flow. Here are the selectors, and again a change. This time they've been included as a single separate file instead of with the reducers. You can see the action creators here are as simple as can be because they're using a really nice utility called Redux Actions. And the reducers are pretty simple too. That's because in this app, pretty much all of the processing logic is actually in the sagas. Because it's a game, I was finding it really difficult to keep the flow in my head over multiple types of files. Having the ability to centralize it all with redux-saga was a total lifesaver. So that's my story about selectors and sagas. Hopefully you've learned a couple of things and it's inspired you to think about the application of your application's architecture. Thanks.
Rebecca, thank you very much. I would now invite you to sit on the special chair.
Oh, these are comfy.
Guys, just a quick comment, because people were asking already about lunch. There is food coming, so no need to plan anything to go outside. Just after this panel, we're going to proceed with food. Thanks.
Thanks for the talk. What the slides? Did you use MS Paint or something?
No, I didn't. But I'm not very creative, actually. It is a series of images taken from Google and then traced with Photoshop.
Okay, it was nice. So you basically described my life. I mean, we're using React and redux-saga and selectors and reselect and all this stuff. Do you see redux-saga for me is actually the holy grail of handling the business logic. I really, really like it. Do you see any issue with this? Like any problems? Like
I think probably the biggest problem is the one that I said around it being a bit of a learning curve. I think for somebody who's not used to that, especially the generator concept, it's a little tricky to get it. And it also is a bit of a shame. I think a lot of people say that they prefer Redux Observable because it's using observables in RxJS, which is kind of an already, it's already a very well used and very well recognized concept. Whereas redux-saga using generator functions, pretty much nothing else uses generator functions. I've never really seen it. So that is also a bit of an interesting take on it. But for me, it's worth it. Yeah, I love it too.
Yeah, I shoot myself with the foot with Redux Saga a couple of times already until I actually realized that there are some places you don't have to use it. In your opinion, what's the place where Sagas, like some anti-patterns were using Sagas, or where Sagas shouldn't be used? Because what I've seen is overusing something usually leads to bad results.
Yeah, that's totally true. Yeah, I think that it's a balance. So in the examples that I showed with the game, I found that I really had to have it all in one place, but there's certainly cases where I've noticed myself using Sagas for something that could have easily been in a reducer. And like, as I was saying, like reducers, their whole job is to figure out how to change the state. So it's a balance, but that would be my advice, is thinking about the reducers as well.
Okay. I want to mention something like in general about React. Don't you guys, and you, Rebecca, think that React is kind of a why?
A kind of a what?
It's kind of a why. Because you see the library, you think it's easy, like it has really minimal API, and then you start building something.
Oh, yeah, okay.
It's not easy. I mean, you can't build a complex thing without using something more.
Yeah. For sure, yeah. I get this a lot where people are like, oh yeah, I start getting into Redux and now I'm really confused and I haven't really learned like JavaScript properly yet, you know? And like there's such a struggle. I think actually there's a really good, my favorite article on this is, I don't know if you know Pete Hunt, I think, did a really amazing article which is like how to learn React, and that one's been around for a while. It's nice. It's nice in the way that it tells you, you know, do one thing at a time, you know, and do it in order. There's an order to do things in, and don't get overwhelmed thinking that you need to know everything. And also, a lot of the times, as I was saying, you don't even need to use Redux. I think it's very easy for us to automatically jump to these solutions, but a lot of the time our apps just don't need them.
Yeah. Okay. Thank you. Thank you for the talk.
Cool.